For a data set of the pulse rates for a sample of adult females, the lowest pulse rate is 34 beats per minute. The mean of the listed pulse rates is 79 beats per minute, and their standard deviation is 17.5 beats per minute. For the first question, it says, what is the difference between the pulse rate of 34 beats per minute and the mean pulse rate of the females? So basically what it's saying is we're taking the mean and then we're subtracting the lowest pulse rate. So let's just discuss here. So the difference can be calculated by subtracting the mean from the lowest pulse rate or by subtracting the lowest pulse rate from the mean. In this problem, we're going to subtract the lowest pulse rate from the mean. So we're going to go ahead and do that. So if we take the mean, which is 79.0, and then we're going to subtract 34. We'll add the decimal there, and that gives us 45. And that's 45 beats per minute. So the answer to the first question is 45 beats per minute. Next question says, how many standard deviations is that? Meaning the difference found in part A. So what we want to be able to do is the following. I'm going to compare the difference to the standard deviation. Now notice that to determine the number of standard deviations in the difference, we divide to determine the number of groups that are the size of the standard deviation in a difference. So we divide the difference by the standard deviation, rounding it to 2 decimal places. So the difference is 45 beats per minute, and then we're dividing it by the standard deviation that's in the question, which is 17.5. And let's find out what that value is. Now they want us to round it to 2 decimal places, so we're going to take the following. 45, divide that by 17.5. I'm going to round that to 2 decimal places, which is 2.57. So we end up getting 2.57. So therefore, the difference is 2.57 standard deviations. Okay, now the next question says to convert the pulse rate of 34 beats per minute to a z-score. Okay, so in order to do that, a z-score or standardized value is the number of standard deviations, the sample or the population standard deviation that a given value x is above or below the mean, either the sample or the population mean, and the z-score is calculated by using one of the equations below. So here's our sample z-score formula, our population z-score formula. Now in this case, the data are from a sample of adult females, so not all adult females, so we're using the sample formula. Okay, so what's given in our problem? Well, we know that the value of x that's given is 34. We know that our sample mean is 79.0, and we know that the sample standard deviation is 17.5 beats per minute. So now it's substituted into our formula. So z is going to equal 34 minus the mean, the sample mean, which is 79.0, and then we're going to divide that by 17.5. Well, that's going to give us negative 45.0, and then we're going to divide that by 17.5. And so in this case here, we're going to get negative 2.57. Okay, so let's go ahead and check our result. So the z-score is negative 2.57 rounded to 2 decimal places. Okay, now the next question states the following. A value is significantly low if the z-score is less than or equal to 2, and a value is significantly high if the z-score is greater than or equal to 2. Otherwise, the value is not significant. So let's take a look here. So if we want to look at the z-score, we know that the mean, okay, in this case is going to be 0. We know that we have -2 here, and then we have +2 here. Okay, so our value of -2.57 is over here. And so that means that this is significantly low. Now, if it was on this side, it would have been significantly high. And if it was in between, it would be insignificant. And so in this case here, the lowest pulse rate is significantly low.